let's talk about the biggest things in the universe. Now let's start locally to give us some perspective. Earth is the largest of the 4 rocky planets that orbit our sun. But of course, it is not the largest planet in the solar system, not by a long shot. That belongs to Jupiter at 43.5 thousand kilometers. The radius of Jupiter is so large that, according to the electronic astronomy speak and spell-esque thing that my parents got me as a kid, you could fit all the planets inside Jupiter and still have room left over. Now, when it comes to planets outside of the solar system, the largest exoplanet, Rox 42b, which sounds almost like a radio station, is a gas giant like Jupiter, but it sits 460 light years away from Earth. And get this, it's 9 times the mass of Jupiter, and its radius is 2.5 times that of Jupiter. It's insane to think about. But planets, no matter how large they get, are absolutely dwarfed by stars. Take the sun, for example, the largest body in our solar system. It has a radius of 700,000 kilometers. To drive home how big that is, billions of years ago, our solar system formed from a giant molecular cloud that collapsed to form not just the sun, but all of the planets and asteroids and everything that's in our solar system. But 99.8% of all of that mass is contained within one body. But the sun isn't even close to the largest known star. It doesn't even touch it. This is Stephenson 218, and it is big. So big, in fact, that its size is a little bit controversial. If the calculations are correct and you were to replace the sun with Stephenson 218, the surface would extend past the orbit of Saturn. Saturn is about 9.5 astronomical units away from the sun. That's about 1.4 billion kilometers, but that's just the largest star. Let's talk about the largest known black hole. Now, some of you might be thinking I'm going to talk about Ton 618, which by itself is just frighteningly huge. But no, this is Phoenix A black hole with a mass of 100 billion solar masses. That is 25,000 times larger than the supermassive black hole that sits at the center of the Milky Way. This black hole is so large that its event horizon is an estimated 3,900 astronomical units. That's about 100 times the distance between the sun and Pluto. If you were to actually travel the circumference of this black hole at the speed of light, it would take you over 2 months to do so. It is unbelievably large, but black holes, as big as they are, really not that big. Now, this is the Tarantula Nebula. It is one of the largest known out there, but it's not the largest. I just want to prepare you for what we're going to be dealing with here in a second. The Tarantula Nebula is 1,800 light years across, and of course, being deathly afraid of spiders, freakishly arachnophobic, one of the most striking nebula out there is named after a spider. Yay. But okay, 1,800 light years across. That's big. But this is NGC 262. It's not the galaxy that we're going to be talking about. The galaxy is large on its own. It's one of the biggest spiral galaxies out there. But surrounding it is a halo, a nebula of neutral hydrogen gas that is 1.3 million light years across and weighs as much as 50 billion suns. This is the largest known nebula. And just for reference, the Milky Way galaxy is about 100,000 light years across. Now, let's talk about the largest galaxy. This is Alcanaeus. Sorry if I pronounced that wrong. A radio galaxy that has trillions and trillions of stars. But it's not the amount of stars that we want to talk about here. It is 16.3 million light years across. The name, apparently, when translated from Greek, means mighty ass, and indeed it is. But as big as galaxies like this can be, they really do pale in comparison to the large structure of the universe. The universe on a grand scale has these large filaments of galaxies, and the largest known is the Hercules Corona Borealis, a filament of galaxies that is the largest structure in the known universe. If you were traveling at the speed of light, it would take you 10 billion years to travel across. Now, with objects and distances this large, it is impossible to truly grasp. Our brains didn't evolve to need to understand these numbers. As amazing as these things are, the larger the object, the further detached our brains get from being able to really appreciate the size. That fact alone is pretty amazing to me, even if we can't fully grasp the true scale of things. If you like this video and made it this far, please consider giving me a follow, a like, a subscribe, all of the stuff. I'm almost at 10,000 followers on TikTok and a little over 500 on YouTube, and I'd love your help in growing my platform. Thanks. Bye.